So, if you've ever poured your heart and soul into an AI project, you know this feeling, right? You spend months, maybe even years, building this brilliant, super accurate model, only to watch it just completely fall apart in the real world. It is an incredibly common and, let's be honest, infuriating problem. Today, we're going to unpack exactly why that happens and look at a really powerful framework designed to stop it, the Enterprise Resource Triangle.
It really is the question that keeps engineers and product managers up at night. Why do these amazing AI projects with all this potential so often break the second they hit a production environment?
When things go wrong, our gut instinct is to point the finger at the AI. We think, oh, the model must be flawed or our data science was off. But here's the kicker, and what all the data shows, that's almost never the case. The model itself, it's rarely the actual problem.
Okay, so if the brain of the operation is working just fine, where's the failure? Well, it's in the architecture. See, the problem isn't the AI model, it's the entire system that we've built around it that's actually breaking down.
This whole situation creates what you could call the AI failure paradox. We're deploying these incredibly sophisticated, accurate models, but we're putting them inside of fundamentally broken systems. Let's dig into what that actually looks and feels like in the real world.
And the symptoms of this bad architecture? Well, they're felt right where it hurts the business the most. We're talking about crazy, unpredictable latency that just tanks the user experience. We're talking about massive governance headaches trying to manage this chaotic system. And maybe the most painful one of all, spiraling, totally out of control cloud costs.
So to solve this, we have to stop thinking about the AI model as this thing that exists all by itself. We have to start seeing its entire environment and all of the hidden constraints that come along for the ride.
Think about it like this. Your AI model is a world-class engine. I mean, the most powerful, most efficient engine ever built. But what happens if you take that incredible engine and you drop it into a car with flat tires and a weak, rattling chassis? All that power is completely useless, right? The engine's performance is totally capped by the system it's stuck in.
And this really shows you what I'm talking about. An AI model doesn't exist in a vacuum. It lives and operates inside this complex, interconnected, and, frankly, often chaotic environment. And its success is 100% dependent on that context. Now, this environment has three key areas that are constantly putting pressure on your AI's performance. First, you've got device constraints, the user's phone or their laptop with its limited battery and processing power. Second, network variability, that totally unpredictable connection between the user and your servers. And third, the back-end destination limits, the capacity and, of course, the cost of your own cloud infrastructure. Any one of these can become a critical bottleneck that brings the whole thing down.
So how on earth do you design a system that can handle all of these competing variables? Well, the answer lies in a mental model called the Enterprise Resource Triangle.
Officially, the Enterprise Resource Triangle, or ERT, is a holistic optimization model. Its whole purpose is to force us to design coordinated, high-performance AI systems by treating every single part of the environment as one interconnected unit.
And here it is. This is the core concept. The ERT makes you look at your entire AI system through three interconnected pillars: the device, the destination, and the landscape that connects them both. Let's break each one down.
First up, you've got the device. This is the user's entry point, their phone, their web browser, an IoT sensor, whatever. It has its own very real-world limits on power, memory, and processing that we just absolutely cannot ignore.
Next up is the destination. This is your backend, all that infrastructure usually running in the cloud. It's where all the heavy lifting happens. The servers crunching the AI model, the databases holding all the info. Now, this is where most teams tend to focus all of their attention. And finally, we have the landscape. This is the network that connects the device and the destination. We're talking about the internet, Wi-Fi, 5G, and it is just full of unpredictable changes, bottlenecks, and latency that can bring even the most powerful backend to its knees.
Okay, so now that we get the three pillars, we can get to the most crucial part of the ERT. It's not enough to just understand them on their own. The real magic is in achieving balance, and why trying to optimize in silos is a total dead end.
Let me paint you a picture of what happens in most failed projects. Teams focus on just one corner of the triangle. Imagine the back-end team builds this absolute beast in the cloud, the destination, and it can process a request in 5 milliseconds. Awesome! Meanwhile, the app team builds a beautiful mobile UI, the device,
But nobody thought about the network, the landscape. The data payload is so huge that it takes 5 seconds to download on a normal 4G connection. So the user just thinks the app is slow and broken, even though 2/3 of the system is perfectly optimized. That's siloed thinking, and it is a guaranteed recipe for failure.
So, the crucial point is this. If you remember one thing from this whole explainer, make it this quote. Applications fail at the weakest vertex. It doesn't matter how strong your other 2 points are. Your entire system is only as strong as its weakest link.
The takeaway here is so simple but so profound. When you design for balance across the device, the destination, and the landscape, your system becomes resilient. Balanced systems are the ones that actually survive contact with reality.
And this idea of building resilient, balanced systems, it leads us to a new mandate for AI, especially when we start talking about the unique challenges of building in the cloud.
See, building AI in the cloud isn't like building traditional software. It comes with this whole unique set of challenges. You've got the demand for continuous inference, where the model is always on. You have these bursty, unpredictable training loads that can make your costs go through the roof. And you have to wrestle with incredibly complex governance and cost management every single day.
Because of these huge challenges, thinking about your architecture in this holistic way isn't just a nice-to-have anymore. For cloud-based AI, using a framework like the ERT is mandatory, not optional. That is, if you actually want to succeed.
So I'll leave you with this one final question to take back to your own projects. Look at your application through the lens of this triangle and ask yourself, honestly, what is the weakest vertex in your system? Because that's not just where you're going to find your next failure, it's also where you're going to find your next breakthrough.